Last class, we saw the relationship between angles and the sines of opposite sides. So we're going to use this relationship right here to bypass all making a vertical, as we did in the last example, in the last lesson, and see how easy it is to do. There's only two kinds of equations you need to solve. Find a side, little a, or find an angle. And in that case, we have to use the second function on our calculator to be able to find that angle. So what I'd like you to do right now is pause the video and as accurately as you can measure all the sides of this triangle and all the angles. So remember, opposite of A is little a, opposite of big B is little b, and opposite of big C is little c. So what I'd like to do, measure all those angles, measure all the sides, fill in the table, and the last column is what we want to see. Okay, so you measure all these sides, and I'm going to put in my measurements, and as long as yours are pretty close, then that's good enough. Now, one of the problems with measuring is there is measurement error, and there will be some measurement error right here. But this is the data I got. So again, I'm going to do one quick example of one of these last three boxes right here. And this is kind of what we looked at last day. So this idea of what is a little a, 6.9, divided by sine of big A, which is 58. And when we simply punch in that into our calculator, we get 8.13, and that's what I got. So that's what all I simply wanted you to do. And what I want you to notice is, although the last three columns are not exactly equal, they're pretty much the same. And we can take the error down to measure bias. So if I just write down what I just said, are not exactly the same. We can see that they are very close. And very close meaning they're equal. And we're going to blame measurement error. So there's a really simple verification of that idea we looked at last day. There's a relationship between the sides and the sine of the angle opposite, and this is a nice tidy little formula, and this formula is actually called the sine law. So the valuable thing about this equation above that I highlighted is that it has three parts, and we can separate because of the equal sign. So if we know information about A and B, then we don't need the whole equation. We just need this part of the equation. And if we know information about A and C, well, again, we don't need all three parts of the equation. We only need this part. And similarly with B and C. So it's a very powerful, very compact little formula. And what happens is it actually allows you to solve easier than in grade 10. So let's have a look at an example. Let's see if I can drag this over. So let's have a look at an example right here. So in these two examples, I want to find particular sides. So again, what I want you to recognize, in order to use the sine law, this is what we need. We need to have, I'm going to call it one matching side and angle. So in this one right here, here's what we have. We have this angle down here, which isn't entirely given right now, but we have that side as well. So again, based on what we know about the interior angles of triangles, it's not exactly given, but there's our matching side. We have big C and we have little c, and then what we can then go ahead and do it quite simply, is to use parts of our sine law, the parts we need, in order to figure out the unknown side. So let me just do side A first. Again, it really doesn't matter. And I'm going to write out the formula. It's always a good thing to do. So given that I have A information and C information, then I'm just going to write it out like that. And then simply what I'm going to do is I'm going to plug in the pieces I know. Well, I don't know little a, but I do know angle A. And I do know side little c, and I do know big C. Now, if you wanted to right now, you could change sine of 80 and sine of 40 into actual numbers. But what I'm going to do is I'm going to isolate little a. And again, the way we undo a division is with a multiplication. So if we simply multiply this side by the sine of 40 and that side by the sine of 40, these two things cancel out, and I'm left with one simple statement that my calculator loves. And I'll show you what I mean in a sec. So again, if you don't feel comfortable, the first thing you're going to do is you're going to change sine of 40 into a decimal, sine of 80 into a decimal, and then you're going to do the exact same thing. You're going to multiply either side and multiply it all out. And when we do that, here's what we end up with. So just to show you what I did, we have 40 times sine of 40. And again, if your calculator opens up a bracket, close it. And we're going to divide it by the sine of 80. So again, my calculator doesn't care how I do it, just wants to know. And we ended up with 26.1. So side A is 26.1, I guess in this case, centimeters. Now, if we want to do C, or little b, sorry, we're going to do the exact same way. And again, get in the habit of writing down the relationship. It really helps your brain. And plug in what you don't know and what you do know. So I don't know little b, but I do know big B. And I know everything else. And again, we're going to do the same thing as before. We're going to multiply over whatever that is. What you do to one side, you do the other. And we're going to end up with little b is equal to 40 times the sine of 60 divided by the sine of 80. And again, we'll do this on our calculator, because our calculator really likes that thing, even though our brain might not. So when doing this one, we're going to do 40 sine 60, again, close your brackets, divided by the sine of 80. We're going to get 35.2. So this will equal 35.2. And again, I want you to look at the triangle, and I want you to ask yourself, do those answers make sense? And remember back to what we did at the very start. Sides opposite bigger angles are bigger than sides opposite smaller angles. The biggest angle is C, and the biggest side is 40. The smallest angle is 40, and the smallest side is 26.1. So I think my answers make sense. Okay, example number 2, solve for y. Now again, we need a matching pair, and that's really important to highlight right off the bat. And there we have our matching pair right there. But the other thing we need to know is one piece of information. If we want little y, we need big Y. And again, we know what big Y is really simply. Big Y is 67 degrees. Again, interior angles of a triangle. So now we can go ahead and use the Z information and the Y information. We don't need the X information. So the part of the formula we really need is this part, or this part. Now remember, the letters don't matter. If you're really uncomfortable, label them A, B, C. And we'll plug in what we know. Y over sine of 67 is equal to 3 over sine 25. Again, if you're not comfortable, you change those trig into decimals. But I hope you're getting more and more comfortable with just leaving them alone. And again, what we end up with is y equals 3 times the sine of 67 over the sine of 25. And that's going to equal, well, that's going to equal a number bigger than 3, right? 25 degrees is the smallest angle. So this answer to this question has to be bigger than 3. It's a way to check our answer. So let's plug that in. Let's see if, in fact, we do get that. So 3 sine 67 divided by sine of 25. And we get 6.5. And even though I don't know right now if that's absolutely right, I'm pretty sure it's right because it actually fits what I think. Okay, the very last one, it's the only other kind of question we need to solve, is when we solve for an angle. So again, first thing we always have to check is for a matching pair and to have information about the other one, so we have little s. So this is our ratio. And what we will use is, we'll use S and Q. Now, one of the things we talked about the other day is we can flip the relationship. And it's always easier to solve something when the unknown is on top. So again, what I would really recommend is, instead of writing little s over sine when I find an angle, I would do the sine over little s and the sine of q over little q. And remember, eventually we want to solve for s. It's a lot easier when it's on the top. And in the previous video, I showed you why you can do that. So let's just go ahead and finish. Sine of s over 6.5 is equal to the sine of 50 over 5. Now again, a quick little question right now. You should have an idea about something about angle S. And the idea you should have is it has to be greater than 50 degrees because 6.5 is bigger than 5. Therefore, the angle opposite 6.5 has to be the angle bigger than 5, which is 50 degrees. So we're going to isolate S, but before we can do that, we have to get rid of the 6.5. And then we're going to use that button on our calculator. So what we have is sine of S is equal to 6.5 times the sine of 50 divided by 5. Now, what I'm going to do is I am going to figure out what that equals. And again, I'm going to push the buttons on my calculator. And this is what happened when I pushed the button. 6.5 times sine 50 divided by 5 is equal to 0.9959. And again, what I want you to remember right now is this is when you press the second button. Whenever you want an angle, you will always press that button. So in this one right here, your calculator will put that, and it will know that you want it to figure out an angle. And when you do that, the angle that it will give you is 85 degrees, which makes sense. So when those are the only two kinds of equations you're going to have to solve. And the easy part is you can always flip it upside down and make it easier. And I'd really recommend you flip. So past that, as I just said previously, this is another form of the sine law. and all it is flipped upside down, and this one is best defined an angle. Just because the thing you want to figure out is on the top, and it's always easier to do that. So the only other thing that's going to pop up is language. So here is some vocabulary that you need to know that pops up in trigonometry often. 3 things: angle of elevation, angle of depression, and you have to know how to read a compass direction. So an angle of elevation is simply angle made from the horizontal. That's always important. These angles are always from the horizontal in an upward direction. So again, if you are normally feeling elevated, you're feeling up. So here would be what an angle of elevation would look like. It would look like this angle right here. And again, from the horizontal, imagine looking up at a tall building or something like that. Angle of depression is the angle made from the horizontal again in a downward direction. So again, an angle of depression, depressed, you're feeling down, right, would be this angle right here. And again, always from the horizontal. And then finally, compass directions, as we see in example number 4, it's basically how you read it. So there's going to be 3 parts. And the first letter signifies your starting direction. And it's usually north or south. The number represents the degree rotation. And the last letter tells you which way. So we'll do a couple of these down here so you see what I mean. So in this last example, I just wanted you to draw the diagram. I don't want you to do anything else. But again, it's really important that you can draw diagrams. Pictures are super helpful. So here's what this question is saying. You have a boat, and I'm just going to label it. I'll put my boat right there. So here's the boat. And again, what it says is the compass indicates that there's a lighthouse to the left and a lighthouse to the right. The lighthouse to the left is located north 30 degrees west of the lighthouse. So first of all, we need our little compass setting: north, west, east, south. And the way you do this is you always draw a little compass setting. And again, as I say, the first letter tells you which way. So this is north. The second one tells you how many degrees you're going to rotate, and the third letter tells you which way you're going to go. So in this example right here, I'm going to be pointing north, and then I'm going to go 30 degrees west, and that is the path in which the lighthouse is. Now there's not enough information here to tell how fast the boat is going, how far the boat's going, or things like that, but that doesn't matter. So here's this picture right here. That's what we mean by north 30 degrees west. So second part of the picture then says, well, the other lighthouse, here let's label that A for lighthouse A. The other lighthouse is north 50 degrees east. So in this one right here, again, we're going to look north and we're going to rotate 50 degrees east. And this part is on there. So here's this idea of how to draw using compass directions. Okay.